Question 3, again, was taken from 2018 paper 1. It was question 12. And here we have some exponential growth. This is the value of a vintage car. It was first valued on the 1st of January 2001, okay, which is stated here. And the model is AP to the power T, where A and P are constants. Now we're given some information which is essential if we're going to figure out what these constants are. So we're told that the car was £32,000 on the 1st of January 2005. Please pay close attention to this. 2005. Now, the initial value was 2001, the initial valuation. So we have a difference of 4 years since the starting point, the initial valuation. So we can say that when T equals 4, the value of the car was £32,000. So I'll just state that as 32,000 because we know V is in pounds. We're also told that on the 1st of January 2012, the value of the car is 50,000. Now, again, if you subtract the years, 2012 subtract 2001 is, of course, 11 years. Okay, I hope that doesn't catch you out. Okay, you've got to read the information really carefully before you start. Now, the important thing here is we now have essentially 2 coordinates on the graph of our model. So if we sub those in, we can hopefully find a value for P. We're asked to find it up to 4 decimal places. So if I sub everything in, we're going to have 32,000 is going to be equal to capital A P to the power 4. Okay, that's our first equation. And then 50,000 is going to be equal to AP to the power 11. Now, we solve these simultaneously. You've done this many times. If you'll pay close attention, if we divide the equations, so if I say I want to do equation 2 divided by equation 1, we can eliminate A from our equation. Okay? So let's do that. So we're going to have AP to the power 11 is equal to 50,000. I've just written it the other way around. Divided by AP to the power 4. So that's going to be divided by 32,000. As I've said, the A's will cancel, which is what we wanted. Okay. So using our laws of indices, we can now see that P is going to be to the power 11 subtract 4, which is 7. Okay. And on the right-hand side, if we simplify that, we'd have 50 over 32, but obviously that will simplify to 25 over 16. Okay. And again, this is misleading. You might question yourself whether you've actually got the right power of P here because you've got these nice square numbers on the right-hand side. But it is correct. If we take the 7th root of 25 over 16, now I'll have to do this on the calculator. Okay, so just type it all in. I do 25 over 16. Now, all that needs to be raised to the power. In fact, I'm going to do that again. Let's put it in brackets. So do 25 over 16. Let's come out of that, close the bracket, raise all that to the power 1 over 7, which is essentially what the 7th root is, isn't it? And we get 1.0658. Now that will be to 4 decimal places. So we write that down to the accuracy it's specified. So use the pen on Zoom. So 1.0, I've forgotten it already, 658. And state the accuracy to 4 decimal places. Okay, keep that handy on your calculator because we're now going to find or show that the value of A is approximately 24,800. Okay. So if we sub the value we've just got into one of the equations, if I do the top one, just to explain what we're doing. So for part B, we're going to sub P equals 1.0658 into equation 1. All right, now if we do that, we're going to get 32,000 is equal to A multiplied by the 1.0658, and that's going to be raised to the power of 4. Okay, so to get A, if we take the 32,000 and then divide that by our 1.0658 to the power of 4, we should get an answer. Now, it says show that it's approximately 24,800. No problem. We'll just erase some of this so we've got a bit more space. Okay. So we've got our answer on the board. So I need to raise that to the power of 4. Okay, so just type that in. Okay, now this is what I've got to divide by. So if I take 32,000 and divide that by my answer here, so 32, 1, 2, 3, divide by answer. Okay, we get £24,796.80. Okay. $24. Right, it's not in pounds, sorry, because we're talking about the value. $24,796.80, because we're talking about currency, which is approximately 24,800 as required. Now for the rest of the question, it says, with reference to the model, interpret the value of the constant A. Well, A is the 24,800. This was the value of the car. So notice it's a vintage car, so the value is growing. But it was the value of the car on its first valuation. So it was on the 1st of January, 2001. The P to the power T, that's the exponential growth, okay, over the years. So the constant P is the in fact, let me state it properly. So P is the factor by which the value of the car increases. And that's the increase per year. So increases each year. Okay. Now, looking a bit more closely at P, notice it's a multiplier. So it's about, you don't have to state this, but interestingly enough, it's approximately 6.6%. So the multiplier is about 1.07, isn't it? Or 1.066. So it's a 6% growth, and it's compound interest. So it's increasing year upon year. So that's that. We've completed those. For the 4 marks in part A, you would get a method mark for showing that P to the power 7 is 25 over 16, so which I didn't state earlier, and you would get an accuracy mark for getting the correct value of P. You would also get a method mark for subbing in your value of P into one of those equations and for then getting or showing that A is approximately 24,800. Okay, so it's 4 marks for all that. Now, for the last part of the question, we have to find the year during which the value of the car first exceeds 100,000. Okay, so to do that, we set up an equation or an inequality. Now, it's up to you how you want to do this. I'll do it as an equation, and then we'll just have to think carefully about what our answer is going to be at the end. So for the value of the car, we now know the value of the car is about 24,800. And then that's multiplied by our P, which is 1.0658 to the power T. Okay. Now, we want this value to exceed 100,000. So we're going to set up an equation. So we have 24,800 multiplied by 1.0658 to the power T. When is that equal to 100,000? First of all, we want it to exceed 100,000, but let's see when it's equal to 100,000 first of all. All right. So at the moment, I've got the 1.0658 to the power T. So I need to solve for T at some point. I also have this 24,800 multiplying it. So I'm going to divide both sides by 24,800 first of all. So this is going to give me 1.0658 to the power T. Okay, and then on the calculator, which I will just drag over to the side. So we're going to have 100,000, okay, divided by 1.0658. Nope, wrong. Divided by 24800. Okay, so we get 125 over 31. That's fine. I'll leave it like that. Okay, now then, the value we want is locked in the power. Okay, so you could use BAPS here. You could take logs of both sides. I'm going to take natural log of both sides to release that power. Okay, so applying natural log to both sides, we're going to have ln. You can take any log to any base you like. It doesn't matter. The laws still apply. That's going to be ln of 125 over 81. Okay, the power now comes down to the front. So we're going to have T ln 1.0658 is equal to ln of 125 over 81. Now, to get T on its own now, we have to divide by this number. It's just a number. So it's just like solving an equation. Just so we divide both sides by that. And let's see what we get. If we go to the calculator, if I take the natural log of my answer here, so I've already got 125 over 31, natural log of my answer. Okay, so that's what the value on the right-hand side of the equation is. I can then divide that by the natural log of 1.0658, close the bracket, and this will be my value of T. Okay, so we've got T is equal to 21.88. Now, plus some extra stuff. Now, we don't have to worry about an accuracy here, okay? But we know that after 21.88 years, the value of the car will reach the £100,000 mark. So we need to state in which year does the value exceed 100,000. So it's going to exceed 100,000 in the 21.88th year. Now, if we think about where we started from, we started at 2001. So if I take the 2001 and add the 21.88. Okay, that's going to give me 2022.88. Okay, so it's coming to the £100,000 mark towards the end of 2022, but it will exceed £100,000 also in 2022 as well. Okay, if all I have to do is make this decimal here just ever so slightly bigger, and the value will exceed 100,000. So the year is going to be 2022, which is this year. Okay, so that concludes question 3.